Hello. ML-Quadrat adopts the model-driven software engineering paradigm and the domain-specific modeling methodology with full code generation. Various model-to-code transformations, also known as code generators, can generate the full implementation of the desired IoT services for diverse hardware and software platforms, programming languages and APIs. Following the Thing-ML methodology, the user of ML-Quadrat needs to model the heterogeneous and distributed IoT services through a number of components, called things. Things are analogs to classes in the object-oriented design. Each thing may have one or more ports for the asynchronous message passing with the other things. The ports, the messages and the local variables, called properties, must be defined for each thing. Moreover, a finite state machine, also known as a state chart, must model the behavior of each of the things. There is an imperative action language that supports the event-driven programming paradigm in the state machines. In addition, each model instance, that can include several things, may have a configuration section at the end, which defines the instantiations of the things, like objects that are instantiations of the classes in the object-oriented design, as well as the connections between the ports of the things for the asynchronous message passing. Finally, the main innovation of ML-Quadrat compared to Thing-ML is the data analytics section, which is an optional section of the model instance, that defines the data analytics and machine learning capabilities of the thing. In this demonstration, we concentrate on a specific use case scenario related to our case study for the validation. Here, we see a sample software model instance for the mentioned use case scenario in the Xtext-based textual model editor of ML-Quadrat in the Eclipse IDE, namely the Eclipse Modeling Framework, EMF. Now, let's see the same model instance in the tree or form-based editor of the EMF. The third option would be to use any external text editor program like VI, Nano or Notepad to edit the text-based model instance files, which have the .thing-ML extension. However, the disadvantage would be that you would not get any support at the design time regarding the syntax and semantics of the domain-specific modeling language of ML-Quadrat. In other words, it would be more difficult to come up with a model instance that is both valid and complete, so that we can generate the full source code out of it. No matter how you created your software model instance, you want to generate the source code of the target IoT service out of your model. To this aim, you may simply run the shown executable jar file, as also explained in the online documentation. ML-Quadrat offers the full code generation in a fully automated manner. The generated code is also capable of generating the required machine learning models, training them with the available data, deploying them, and possibly retraining them as necessary. Also, one may bring an existing pre-trained machine learning model. The latter offers a lot of flexibility, since you may use any arbitrary architecture for your machine learning model in any learning algorithm, technique or method, whether they are already supported by the domain-specific modeling language of ML-Quadrat or not. This is how the generated code, for example in Java and Python in this case, looks like. So far, we demonstrated the open-source research prototype ML-Quadrat. Now, my colleague from DriotData is going to explain how they are exploiting, extending and commercializing the technologies of ML-Quadrat for a different user group.
At DriotData, we are currently developing a web-based low-code platform with a drag-and-drop dashboard to let the domain experts who are not necessarily programmers or AI experts create their smart IoT services themselves. Let us take a quick look at our minimum viable product, MVP. This is version 1, that is web-based with a textual model editor. The user can design the target IoT service as in the desktop version, using our domain-specific language. Then, they can click on Generate Code and finally download the generated solution. Our code generators are implemented in Java and can generate code in various languages, like Python. Now, this is our second version of the MVP that is being developed via the EMF cloud projects, such as the Eclipse Thea and GLSP. We have a diagram-based model editor, as well as a tree or form-based model editor. Thank you and see you.